Okay, so our last section we're going to look at this week, we're still in section 2.1. We're just going to look at the second part of it. Okay? And it's on what we call angles and their measures. And we're going to learn two different formulas. Okay, we're going to learn a formula for what's called arc length and another formula for area, okay, called area of a sector. Both of those formulas require that we know how to change degrees to radians. Okay, so that's why we did that yesterday. Okay, so I'm going to start out with this diagram. Okay, and what I've basically drawn here is a circle. And inside the circle, I've put two angles. Okay, this Greek letter is called theta. It's just a circle with a line in the middle. And then I have another angle that I've called theta 1. Theta in trig is kind of like using x in algebra. It's just a very common letter that we use when we don't know an angle. And corresponding to those two angles are two arcs. If you trace the rays of angle theta, they hit the edge of the circle right here and right there. And between those 2 points, I've drawn in that red line. That's an arc. And then I did the same thing for theta 1. If you trace the rays, it hits the edge of the circle there and there. And then between the 2 points I just drew, I drew in another arc, and I called it S1. So S is the arc that goes with angle theta. S1 is the arc that goes with theta 1. And there's a relationship in this diagram between the size of this angle and the size of this arc. Anyone have a guess what would happen to the size of the arc if you made the angle half as big? What do you think would happen to the arc? Yeah?
It would decrease by half.
Yeah, the arc would also become half as big. So there's a direct relationship, we call it directly proportional, between the arc size and the angle size. If you make this arc, I'm going to erase this in a second, but if you make that angle half as big, then you just made the arc half as big. If you make the angle double the size, you make the arc double the size. Okay, so those two things are what we call directly proportional, okay, which allows me to set up a proportion. I can set the proportion up lots of different ways, as long as however I do it on the left, I do the same thing on the right. I'm going to start with arc size over angle equals arc size over angle. So I set it up as arc over angle equals arc over angle. And that's a proportion. And the only reason I can do that is because arc size and angle size are directly proportional. If they weren't, I couldn't set up a proportion. Now, the problem with that is that we don't know anything. Okay? It's kind of like if I wanted you to convert between, say, feet and inches. Okay, what's the connection between feet and inches?
There's 12 inches in a foot.
There's 12 inches in 1 foot. You have to know one side of the proportion already to start. Okay? And then you can fill in anything you want on the right-hand side. Say you had 79 inches. And you wanted to know how many feet that was. That's fine. We just cross-multiply and we can solve it. But the point is, you have to already know something to start with. Okay? Like Ryan just said, in 12 inches, there's 1 foot. Same idea here. We have to already know something to start with. Okay? And that's what we need to figure out. So, now, before I do that, just because I picked a 12 and a 1, okay, well actually I didn't pick it, that was given to me. Do these two numbers limit the numbers I can plug in on the right-hand side?
No.
No. I'm using something specific to figure out anything else I want. Okay, so we're going to use something specific on one side to then allow us to figure out anything else we want. All right, so we're going to let theta 1 be something specific. anybody remember what I said yesterday about if the size of this arc happened to be exactly the same length as the radius, how big that angle is right there? You may remember? Yeah?
1 radian.
1 radian. So we're going to let theta 1 equal something specific. We're going to let it equal 1 radian. Because if we do that, we already will know the length of the arc. If you let theta 1 equal 1 radian, that would automatically make the arc the same as the radius. And you'd be given the radius in the problem that you'd be solving. Okay? So this is kind of the specific fact that we're going to use. If theta 1 is 1 radian, then the arc is automatically the same size as the radius. We know that. Okay? So now we're going to fill that into our proportion, and then we're going to come up with a formula for arc length. Right, so let's fill that in. So we're going to leave the s and the theta on the left. Okay, we're not going to fill anything in for that. But on the right, we're going to fill in r for s1, and we're going to fill in 1 for theta. So what I just wrote right here, that is just like this. It's the fact that I can start with to figure out anything else that I want to know. If you didn't have that, you can't do anything. Okay. Right. Now, how do you simplify a proportion? What do you do to solve it? You remember? Yeah. We cross multiply. So what's s times 1? About, yeah, s equals, and then we do the other diagonal, r times theta. We can't really do anything with that. Theta r, or the way our book writes it is r theta. Yep, same thing. That is the formula for calculating the length of an arc in a circle. You have to be given 2 out of 3 of the things in that formula in order to find the third. Okay? So they'll either give you the r and the theta and you find s, or maybe they'll give you the s and the r and you find theta, but they're always going to give you 2 out of 3 things. Now, way back at the beginning, we assumed that theta 1 was equal to 1 what? What is that? 1 radian, right? I didn't write anything there because we don't write it if it's radians. So because we made that assumption that we were working in radians early on, this formula only works if your angle is in radians. So if they give you an angle in degrees, the very first thing you want to do, change it to radians. Okay, so S, that's your arc length. And R is your radius. Yeah, radius. Okay, and theta, that represents your angle. And again, we already said that it's in radians. Okay, any questions on that formula? Okay, now we'll use it to try some different problems. Some problems they can write out like a whole bunch of stuff to describe the problem, okay, like this one. Or they can also just give you a picture, like we're going to do in the next problem. Okay, you can do it either way. So example 1 says, find the length of the arc. Okay, so we've got a circle. Inside the circle, we've drawn an angle of pi over 3 radians. And the radius of this circle is 4 inches. Find the length of the arc.
Would pi remain in the answer?
It is possible that pi would be in the answer, yep. If they want you to round to 2 decimal places, that'll be written on the test tomorrow. Okay, so there's 2 things we have to fill in for. Okay, we've got pi over 3 and 4 inches. There's my formula. S equals r theta. All right, so Becca, out of the 2 things I circled, can you tell me what letter I would, well, either one of these numbers, what letter you would plug them in for?
I'm not really understanding any of this.
Not sure?
4 inches is r, the radius of pi over 3 is the theta.
How do you, yeah, can you explain how you know which one is which?
Central angle,
Yeah, it says central angle.
so that's the,
So,
that one has to be radius.
and the other one says radius. So the angle is pi over 3, and the radius is 4. Okay, so any questions on why those are going to be the 2 things that one of them is S and the other one is R? Okay, so let's fill in pi over 3 for my angle. Let's fill in 4 for R. And we're going to find S. There's really not a lot to do. You just multiply straight across. If you want to make 4 a fraction, you could put it over 1. And you get 4 times pi divided by 3. Now we just have to put a label on that. What does S stand for again?
The arc length.
Arc length. So let's go back up. What units did this problem use for length?
Inches.
Inches. Okay. So that means this is 4 pi over 3 inches. If they wanted it as a decimal, then you just type it in. 4 times pi divided by 3. And it's about 4.2 inches if you rounded it off. Okay, so any questions on that one? All right, let's try this one. It's the same directions. This time I just drew a picture rather than writing it all out. It says find the length of this arc. So you got a circle with an 8-foot radius and an angle of 130 degrees. So besides having a picture instead of writing it all out, what's different here?
It's in degrees, not radians.
It's in degrees. Can we use it in degrees?
No.
No. Remember, this formula, S equals R theta, has to be in radians. So that's the first thing I'm going to do. Off to the side, I'm just going to convert degrees to radians. Okay, so to change degrees to radians, Connor, what do I multiply by to do that? Pi, and then divide by? Perfect. Pi over 180. I can reduce by 10. So I get 13 pi over 18. That's my angle. Now from here, it's just like the last problem. Just fill in what we know. S equals, Emily, what's my radius in this one?
8.
Yep. Oh, that's right. I'm sorry. We have to.
Sorry.
That's okay. It was in unison. So we got, our radius is 8. My angle is 13 pi over 18. It doesn't matter, you put the whole thing over 18, it's the same. And all you can really do there is reduce a little bit. What can we reduce 8 and 18 by? 2. So we can make that a 4 and a 9. So my arc length is 4 times 13 pi. What's 4 times 13 pi? 52 pi divided by 9. Okay, now the last step is just to remember we just found S. S is arc length. So we found a length. What are my lengths in this problem? How are they measured? Feet. So we're going to put 52 pi over 9 feet. Any questions on that one? Okay, so that's finding arc length. Let's try one that uses the same formula, but this time you're finding something different. Now you're going to find the angle. All right, so Irene, I see we got 2 numbers there. We got the pi over 4 and the 12. Can you tell me what the pi over 4, what letter it gets plugged in for? For theta? Well, the last line says find theta. So the angle is what we don't know.
It's the length.
Which length? Because we have the radius, which is a length, and then we have the arc, which is also a length.
Yeah.
It's the arc. See, because it says we have an arc length of pi over 4. So, Emily, in the front, if we plug that in for the arc length, which letter is that? S. So we're going to fill in pi over 4. How about the 12? Cameron, what's that?
The R.
Yeah, that's the arc, radius of 12. And now I'm going to solve for theta. So Zach, how would I move that 12 over to the other side? Yeah, we would divide. And dividing the other side by 12 is the same as just putting a times 12 in the bottom of that fraction. So divide by 12. We get an angle of pi over 48. If my pen changes color, I don't know why it does that. So it's all supposed to be the same color. So pi over 48. Now that's the, what is that again? We just solved for the angle, which is measured in radians. So do I need to put anything on that? No, we just leave it like that. That's pi over 48 radians. Okay, so there's a problem where you're solving for the angle. So we've solved for the arc, we solved for the angle. Last one we're going to do is solve for the radius. Any questions on that one? Okay. Actually, I think I just have it down here. Okay, find the radius. All right, so they're not wording anything here, so I just have to look at what they've given me. The 36, that's the angle because it has a degree symbol. So I know that must measure an angle. And the 13, that's the arc. Okay, how about Rudy? Can you remind me, what's my formula again?
It's
r theta. Okay. Before I plug into that, anything that I want to be careful about? 'Cause I just gotta be careful here. Alex?
Change the degrees to radians.
Yeah, we have to change the degrees to radians. So I'm just gonna do this one out. So 36 degrees, that's pi over 5. Yeah, it's pi over 5. Okay, so if you want to do it all out, you can check and see that I'm right, but it is pi over 5. Okay, so now we have this 13. Faith, what is that 13? What letter does it get plugged in for? Yeah, I'm going to plug that 13 in for S. That's very good. So S, the question is find the radius. So I don't know the radius. That's an R. And my angle is pi over 5. All right, so in this case, we're multiplying a variable by a fraction. So there is a way to move the pi and the 5 to the other side at the same time. Yes?
What you do to get pi over 5?
I converted degrees to radians. I just didn't write it out. So I multiplied by pi, and I divided by 180. It's just one I just remember that one, just because it's a nice number at the bottom, 5. Okay. Yeah?
You can multiply by the reciprocal.
Yeah, and what's the reciprocal?
5 over pi.
Yep, 5 over pi, multiplied by 5 over pi. What that's going to do is cancel the pi's and cancel the 5's at the same time.
And you end up getting 65 over pi.
Yep, and that's the answer. So 65 over pi, and that's my radius. Okay, is radius an angle or is it a length? It's a length, so I got to go back up, look at my lengths in this problem, feet. Okay, and those are the only types of problems you would have on the test about arc length. Okay, they're going to ask you to find one of the 3 things. Okay, any questions on that? Okay. So the last formula we're going to look at is area of a sector. All right. So first of all, what's a sector? Okay. Think of a sector. It's shaped like a piece of pizza, a round pizza cut up. Right? It's got 2 sides that are straight, and then the 3rd side at the top is an arc. And I've drawn pretty much the same diagram I had last time, except instead of focusing on the arc length, I'm focusing on area. Okay, so I'm focusing on the area of this region. So I have an angle theta, and then the area of that arc, another angle theta 1, and then the area of that arc. Now, I'm going to start out with the same question I did with the last formula. If you double the size of this angle, what do you think would happen to the size of this area? Yeah, Ryan?
Still double.
It would double. Okay? The size of the angle and the size of the area that it creates are directly related. How? They're directly proportional. Make this angle half as big, you make the area half as big. Make the angle 3 times as big, you make the area 3 times as big. So again, we can set up a proportion because of that fact, just like last time. Okay? And I'm going to set it up, again, there's lots of ways you can set it up as long as you're consistent. I'm going to set it up as area to angle, area to angle. So area, angle, area, angle. But just like before, I need to already know something. I have to be able to plug in numbers on one side of this equation. or proportion. So the trick we used last time of letting theta 1 equal 1 radian, it's not going to work. Okay, we have to basically let theta 1 equal something. Okay, we can pick anything we want, but we have to pick something easy to work with that we can figure out. So we have to pick something for theta 1. And by picking something really creatively, we will automatically know the size of the area. Just like when we picked the right angle before, we automatically knew the size of the arc. So it's the same idea. Before I give you a hint, does anyone know at what you could let theta 1 be? So you would automatically know the area of the region that it creates.
Does this one have to be degrees or radians?
This one is also going to be in radians when we're done.
Pi.
Okay, let's let the angle be pi. Let's think about that for a second. Let me draw a circle. Pi is equivalent to 180 degrees. So if you let your angle be pi, and you drew a 180 degree angle in the circle, you would be finding the area of that region, which is probably something we could do. But I'm going to say to even let the angle be a little bigger. What could you let the angle be that's even bigger, and you could find the area of the sector? Even bigger than pi. 2 pi. That's 360 degrees. 2 pi, we said that yesterday, is 360 degrees. Well, if your angle is 360 degrees, how much of the circle does that take up?
All of it.
All of it. So if I do this in different colors so you can kind of see it. The black side is the initial side of my angle. The red side is the terminal. That's 180. Well, if I do it with 360, there's my initial side. Where would the terminal side be?
Also right there.
It would be right on top of it. So now, what you've done is you have an angle that's so big, it takes up the entire circle. So technically, you can still call that a sector, but it's a sector that's so big, it takes up the whole thing. So, if we let theta 1 equal an angle that's so big it takes up the whole thing, then our area is just the area of the entire circle. And that's where I hope we remember the formula from geometry. So what's the formula for the area of an entire circle? Yeah.
Pi times radius squared.
Pi times radius squared. And that is going to be our starting point. That's like our 1 foot, 12 inches. That's the fact that we can use that's specific to figure out anything else we don't know. Okay, so now just fill those two things into the proportion up above. We'll simplify, cross multiply, and then you'll get your formula. So we're going to leave the a and the theta. But now we're going to fill in our specific facts that we just figured out. Our 1 foot, 12 inch type connection. So area 1 is pi r squared. And theta 1 is 2 pi. Anything I can cancel out before I cross multiply?
Can you cancel out one of the pi's?
Yeah, you can cancel out one of the pi's in the top and one in the bottom. And that's pretty much all we can do. Now we cross multiply. What's a times 2? 2a. So 2a equals theta times r squared. So the book, the order they write it in is r squared theta. Now, that's not really a formula for the area. That's a formula for double the area. So what would I have to do on each side? Divide it by 2. Divide by 2, divide by 2, which dividing by 2 is the same as multiplying by a half. That's how the book writes it. You could write it either way. So the area of a sector is 1/2 r squared theta. So area of a sector. Okay, we'll just go through the variables, make sure we know what they stand for. What do you think A stands for? Area. R. What's R stand for? Radius. And theta. That's your angle. And what about the angle? What do we have to be careful with? Yep, it has to be in radians again. Okay. So now, when you do a problem on the test, you have to look at, is it an area problem? Should I use 1/2 r squared theta? Or is it an arc length problem? That's the formula we just did before. Okay, so you got two formulas. Okay, so this problem is clearly an area problem. Just find the area. And they didn't write it all out this time. They just have a picture, and we'll just work with that. It's example 5. Victoria, can you remind me again what's our formula for the area of a sector?
Are we looking for theta under dividing under A, or?
So we're just looking for that box that I put around that last formula.
A equals 1/2 r squared theta?
Yes. Okay, so we have A equals 1/2 r squared theta. And let's start with the pi over 6. Okay, Matt, what's the pi over 6?
Theta.
That's my theta. And what units is pi over 6 right now? It's radians. Is that what I want?
Yes.
It's perfect. So we just leave that the same. So I got the pi over 6, and then the 4 centimeters. Katie, what's the 4 centimeters?
Oh, that's a radius.
That's the radius. And we have to square it. Okay, so we'll go through. Orion, what's 4 squared?
16.
And then half of that?
8.
So we have 8 pi over 6. And I can reduce top and bottom by 2. So Mason, what do I get when I reduce that? 4 pi over 3. And remember what we just calculated. We calculated an area. So anyone think they know what the unit should be on this? Yeah?
Centimeters squared?
Yes. Go back and look at your linear, your length measurement. And area is 2-dimensional, so centimeters squared. And that's it. That's how you find the area. Any questions on that one? All right, let's try one where this time they say, find the radius. Okay. Ileana, what do I want to be careful about here before I even start plugging into my formulas? What's something here I need to fix? Yeah, I need to fix this. What do I need to change it to? radians. Okay, if you multiply by pi and divide by 180, that's what you'll get. It's pi over 4. Okay, so now we're ready to plug stuff in. How about, Peter, can you remind me what's my formula again for area?
A equals r squared theta over 2.
Yep, r squared theta over 2, or you can put a half in the front, it doesn't matter. Same thing. Okay, Haley, what is the 8 pi over 3? Is that the a, the r, or the theta? How do you know it's the a? It's on the inside. Anything else about that number that tells you it has to be an area? It has inches squared. It has to be area because of the label. So 8 pi over 3 equals 1/2 r squared. And then my angle is pi over 4. Okay, so now the goal is to solve for r. There's a lot of different things we need to move to the other side, but we can do it kind of one step at a time. Eric, let's start with the pi over 4. How could you move the pi and the 4 to the other side at the same time?
Flip it to be 4 over pi.
Yep, flip it so it's 4 over pi, and then what do I do with that?
Put it on the other side.
Is there an certain, like, something you want to do with the 4 over pi, though?
Divide.
Not quite. We don't want to divide by 4 over pi.
Multiply.
Yeah, we want to multiply. So multiply by 4 over pi and 4 over pi. That's going to cancel the 4s. It's going to cancel the pi's. And it's going to cancel the pi's there. Okay, so let me make that look a little better. So now we have 4 times 8, 32 pi over 3 equals 1/2 r squared. Okay, Paige, what would I do next?
Multiply both sides by the reciprocal.
Yeah, multiply both sides by the reciprocal, which in this case is 2. Yep, so we're going to multiply both sides by 2.
Would you still have pi after 32?
Oh, thank you. Yeah, I meant to cancel that out. I did cancel it out here, but I copied it down. So no, it's just 32 over 3. Yeah, thank you. So multiply by 2. That cancels that. And then multiply by 2. So we get 64 over 3 equals r squared. But now I want just r. So what do I have to do on both sides to get just r?
Square root.
Yep, take the square root and take the square root. And now this is the part where we've talked about one thing you can do with square roots, but one other thing is going to come up right now. To square root a fraction, you do the top and the bottom separate. So what's the square root of 64? 8 over square root of 3. Now, algebraic or numerically, there's something wrong with that. Does anybody know what's wrong here? I haven't talked about this yet.
So you're not supposed to have a square root on the bottom.
Yeah, we're not supposed to leave a square root in the bottom. So do you know how to fix that? Yep. You're going to multiply the top and the bottom by square root of 3. That's how you fix a square root in the bottom. So in the top, there's not really much you can do. You just have the square root of 3 times 8. But now in the bottom, what's the square root of 3 times the square root of 3? 3. It's the square root of 9, or 3. And that is how you would see the answer written. Okay. What's my units on that one? Inches. Okay, radius is in length, and this problem had length. Okay, so when you have to find the radius, that's probably the longest type of problem, just because of the stuff you might have to do with the square root. Sometimes that happens, sometimes it doesn't. Okay, depends on the problem. Okay, and the last one we'll look at is finding the angle. Okay, so again, I'm just going to use the same formula I've been using. Area equals 1/2 r squared. And whenever they give me r, it makes the problem a lot faster. So this one's going to be very fast. 1/2 r squared theta. What's 3 squared? 9. And then half of 9, I'm not even going to do it out. Just leave it as half of 9. Okay? If you do it out, then you're going to have to deal with a decimal. If I do it this way, I can just do a trick with the reciprocal again, and I don't have to worry about the decimal. Right, so Alex, what would be my my last step here?
Multiply by the reciprocal, 2/9.
Perfect. Multiply by 2/9. And multiply by 2/9. So I'm left with an answer of pi divided by 9. Now, if that was a multiple choice question, what if they listed choices like this? Let me see. So if they listed pi/9 degrees, pi degrees, or 20 degrees. Anybody have a thought which choice there is correct? Or if you're not sure which one is correct, which one you could say is definitely not correct? Either way. Yep?
Wouldn't none of them be correct because they're supposed to be in radians and you put a degree symbol?
Well, this answer is correct, pi/9 radians. But it doesn't mean that if it's a multiple choice question, they can't list degree answers.
Would it be 20 degrees?
It is. The correct answer here is 20 degrees. The way I did that is quickly, I just converted pi/9 radians to degrees. Okay? So written like this, if you had to match up, C is the correct answer. Now, what if they did this? Which answer is correct now? A. That idea is going to come up on the test. So keep that in mind. If it's a multiple choice question and they put degree symbols for the answer, you might have to convert what you got, which is in radians, because that's how the formula works, to the way the answer is written on the test. Okay? So just keep that in mind. All right, so on the homework tonight, there's going to be a couple questions where they give you a clock for one, and then they talk about a pendulum for another one. I want to look at the clock one for a second. If you look at all the numbers on a clock, are they evenly spaced or not evenly spaced?
Evenly.
Yeah, they're evenly spaced. So if you had a minute hand like that, and I asked you, let's say 20 minutes went by, and I wanted to know how far the tip of the minute hand moved. From here, if you trace the path to here. The tip of the minute hand moves in what shape? What's the shape that it makes? It makes an arc. And the minute hand itself is like your what? It's your radius. So let's say the minute hand, it could be, 5 inches long. The only thing you'd have to figure out if you want to know the length of the arc is how big is the angle from 12 to 4? Any thought on how you could figure that out? And it helps that a clock is evenly spaced. Everything's evenly spaced. Yeah?
You take 360 and divide it by 12.
Okay, so if I take 360 and divide by 12, I get 30. And can you tell me what that means now?
That's how many degrees are between each number.
That's how many degrees are between each number. From 12 to 1, 30 degrees. 1 to 2, another 30. 2 to 3, another 30, and so on. So now we could say that this is a 120 degree angle between 12 and 4. Now you know your angle, you know the length of the minute hand. It's a very simple problem. Here's another one about a pendulum, okay, swinging back and forth. As a pendulum swings back and forth, it creates an arc. And the length of the pendulum is like your what? It's your radius. So if they said you had a pendulum like 1 foot long, and it was swinging back and forth, I don't know, 30 degrees, that would be the angle right in here, you could figure out how big the arc is. You just need to know the length of the pendulum and the angle. It's a couple problems like that in the homework.
Will it give that information though?
Yep.
Okay.
Yep. It might give it to you in degrees or radians, but remember for the formula.
I'm just saying like in general.
Yep. Great. So any questions on that? Okay. So the homework tonight, same page as last night, 99. 71 to 87. Okay, just the odds. And then 91 to 94, all.